Today we are talking about hydrates. We will show you how to find the hydrate formula and name compounds, as well as show you a simple experiment. Hydrates are compounds with a specific number of water molecules bound to its atoms. Our goal during this procedure is to figure out the number of moles of H2O by using the masses of the hydrate and anhydrate. Anhydrous compounds are hydrates without water or hydrates where the water has been heated off. In this part of the video, I will show you how to find the hydrate formula and name the compound on paper. Today, I'll be using copper sulfate as an example. First off, you'll need to understand the format of a hydrate, which is your compound. Let's say we have 5.00 grams of hydrated copper sulfate and 1.25 grams of H2O. The first thing we need to do is figure out the mass of H2O evaporated. However, it's already given to us. If we are not given the mass of H2O, say in another problem, you'd most likely be given the mass of the hydrate and the anhydrate. You just need to subtract the two in order to get the mass of H2O evaporated if this were the case. For this problem, we are not given the mass of the anhydrate, so we need to find it. You can find the mass of the anhydrate by subtracting the mass of H2O from the hydrate. Our second step would be to convert the mass of water and the anhydrous compound to moles. We can do this by dividing it by the molar mass and multiplying it by 1 mole. Step 3 would be to calculate the ratio of H2O to anhydrous compound by dividing H2O moles by compound moles. Step 4 would be to use rounding rules, then plug the number found in the above equation into compound formula. Let's start with the rounding. If we got an answer of 2.9 moles, we'll round up to 3 moles. Next, we'll plug 3 into compound formula. 3 goes right before H2O to represent how much of it we have. The last step to this equation is to name the compound. In order to name it, we need to know the prefixes up to 10. Mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. You will use these to name the compound. The first part of the name stays the same. For example, copper sulfate will stay the same and just be copper sulfate. H2O, however, will be changed up a little bit. The number in front of H2O will take its proper prefix immediately followed by the word hydrate. So for our compound, we will call it copper sulfate trihydrate. This means that for every 1 copper sulfate, there are 3 H2O.
Hi, I'm Georgia Goldstein, and today we're going to be performing a science experiment to find out how much water is lost when we combine water and copper sulfate. So first we're going to look at our material checklist to make sure we have everything we need, and then we're going to put on our gloves and our goggles so we can stay protected, as there will be a chemical reaction occurring in this experiment. Alright, so first up, you'll plug in your hot plate and you'll make sure it's heated up to about 250. You can see me turning the knob there, and this would be in degrees Fahrenheit. Next, you're going to weigh your Erlenmeyer flask, and our flask weighs about 110.129 grams, and you'll want to write that down. Okay, so we'll take 10 grams, which is actually, in our case, we measured about 10.6 grams of copper sulfate, and we put it in the Erlenmeyer flask. You're going to make sure that you cover the opening of the Erlenmeyer flask with aluminum foil before you put it on the hot plate. And you're going to heat this Erlenmeyer flask with copper sulfate for 10 minutes. You need to set a timer so that you can keep track of time and make sure that you're not overheating it or underheating it. We need to heat it for just 10 minutes for this experiment. So now that it's been 10 minutes, the contents of the flask should be white, and we'll remove the Erlenmeyer flask from the Bunsen burner. Be sure to wear a hot mitt. It is going to be very hot, and it is chemical. So we're going to wait a few minutes for it to cool, put it on a paper towel. So now that it's cool, we'll weigh it on the scale one last time. Our last step will be to subtract this mass, which is the anhydrous, from the original mass of the compound. And this will give us the amount of water that was lost during the reaction. So we're going to, the hydrous mass, we're going to do 120.729 minus the anhydrous. And so here you can see a board with, I have the final mass written on it, and our equation discovers that we have lost 2.619 grams of H2O. And you can look at our equation on the picture of the board here, and you've completed your experiment, and I hope that was helpful.